Hello guys, and welcome to another daily challenge video. Let's begin our question. Okay, so it's a hard question number 2444. Count subarrays with fixed bounds. You're given an integer array nums and two integers, min k and max k. A fixed bounds subarray of nums is a subarray that satisfies the following conditions. The minimum value in the subarray is equal to min k, and the maximum value in the subarray is equal to max k. All right. Return the number of fixed return the number of fixed bound subarrays. A subarray is a contiguous part of an array. Okay, so contiguous means that between the start and the end of the subarray, all the elements are included. And this fixed bounds subarray that they've defined here is a subarray, a contiguous subarray, in which the minimum value is equal to the min k and the maximum value is equal to max k. So it has nothing to do with where the subarray starts and ends. It's more concerned about the content of the array and whether that content min value is equal to min k and max value equals to max k. Let's look at some examples, since this is a pretty confusing question. So 135275, where the min k is equal to 1 and the max k is equal to 5. So first of all, let's see, this doesn't count, this doesn't work, this doesn't work either, but then this already works. So 1 and 3, 1, 3, and 5 is a subarray. What about this? 1, 3, 5, 2. This works also because minimum value of this subarray is 1, maximum value of this subarray is 5, which are the two provided parameters. This, however, doesn't work anymore because 7 is bigger than 5, and no longer is this the maximum. No longer is 5 the maximum value of the subarray. And let's see, none of these, so this has to also be included because 1 is the min k. And here in example 2, there's 4 with min k equal to 1 and max k equal to 1, so all of these will work. So basically all permutations of this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Sweet. Okay. Let's see. How would one approach this initially? Well, what I'm thinking is we essentially do have to go over all of the subarrays in this question, right? We need to look at all possible subarrays and build up the count, the return value of the number of those subarrays that actually align with our condition. However, I'm thinking now that that is going to be an O of n squared solution, which probably will not work. So I'm thinking of a way to basically do it in one line. Let's try the solution for let's try the ON squared solution. So in here we're starting off with the starting index of subarrays, and then the thing is, n can, as we start from any start, we can build up the subarray and keep track of what is the min value and the max value. Min val, let's say, is equal to, what is the condition here? Min val is going to be the max max size, I believe, and max value is going to be equal to 0. And as we go through here, we can say that min value is equal to the minimum of min val, and let's have this n be equal to the nums of end, and max val, max of max val n, and if count if min val is equal to min k and max val equal to max k, we're going to say count plus equals 1 and simply return count. Okay, please work. This would be really cool if it worked. This is an O of n squared solution though, so while this is, okay, it's already taking too long for it to be a, yep. Yeah, so we broke down before we, wow. Yeah, TLE, we've exceeded the time limit. Okay, how do we do this in less time, in less iterations? Let's think of an example array. We have this one, 1, 3, 5, 2, 7, 5. Let's have another one like 0 maybe. Okay, another approach to this could be, okay, let's have some 4s here, maybe another 4, let's have another one here. I'm thinking that we do have this sort of notion of basically like numbers that can absolutely not be included into the array, which are these guys, 0, 6, and 7. There's absolutely no way that they can be included into the array. And let's see, what about these guys? Would these work? So actually this whole thing would never work because min k and max k aren't within these bounds, so we can immediately cut this whole thing off. Here, in between these two things, these being basically, like, these values can absolutely not be in here. So maybe as we're iterating through the array, could we keep track of, like, for example, we're here, right? We're starting, let's have a little start here. We're starting at this one. We see that 0 is less than the min k, so we ignore that. This doesn't fit any of these max or min conditions, so we ignore that too. This also doesn't fit. So let's see, at which point does a subarray become a viable solution? 1, is 1 is viable, so we can maybe somehow keep track of this, and then we can have another one, 3, and then 5. All of a sudden 5 is also here. So this is the first valid subarray because it's in between these two. Well, we don't know about this one, but it's nowhere is there a cutoff. And here it seems like and we have both present. We have both min k and max k present. So this all of a sudden becomes a viable solution. And then actually this one also becomes a solution just because the condition here. Okay, so what if the condition is this? What if the condition for a correct solution would be that min k min indx, min k indx is bigger. Okay, no. Let's say cutoff is equal to 0. So we have a cutoff, which is actually just a index cutoff indx, index number that cannot be included in the solution. What about, oops, sorry, that was wrong. I didn't mean to press enter. Cutoff index of number that can't be included in solution. What if we have a min k indx, index of last min k in nums, and let's have max k indx, index of last max k in nums. And could we just as we're going through, let's say this one, right? Like, let's see. This is my like iterator, I guess. Where's the little thing? As I'm going through this, when I'm on here, I can set, well, first of all, I would be here when I set the cutoff index to 4, 0, 1, 2, sorry, to 3. Then here I would set min k index to 4, and I still wouldn't add anything. Here I would set max index to 4, 6, and then immediately I have to add this to a viable solution. So I have to increment count, and then when I'm here, I have to increment count 2. But what if we have another 2 here? Right? How would I say that this is viable solution and this is a viable solution? And also this is here now. So what if I say that the number between, because let's see, 1, 2, and then for this one it would also be, and then when we're here, we're also doing 1 and 2. So what if it's just the difference between the minimum of these two minus this? Let's try that. So in one go, we're keeping track of these 3 essentially values. Cutoff, min k index, max k index. And as we're doing that, we're appending to count for, let's say, what is it? I in range len nums. We can say that, let's say cut off indx -1, because it hasn't been set yet. Min k, and it's also, since they're indices, we can just, and we're always increasing, we can max k, since it's an index and we're always increasing, we can just set it to either this or, okay, so let's see, cut, first of all, min k indx is equal to min k indx if what is going to be our n nums I, if n is let's say this, if n is equal to min k, then set it to I, else min k indx. So basically, keep it set to the previous index if we have not found a new max or min k. Otherwise, set it to indx. Otherwise, set it to a new one here, I. Just a little ternary statement. So let me write this down. Update to new max min indx if n matches max k or min k. Else keep previous. So the most recent max k and min k are going to be stored here. And now, what about this guy here? This is the so if n is smaller than min k, or n is bigger than max k, then set, could I do the same thing? Pretty this guy up here. Cut off indx is equal to the min of cut is equal to cut off if I, else cut off indx. So we're just keeping this pretty structure of ternary equations. Update cut off indx to most recent index unless found. And then what was our thing? That as we're iterating, right, we're just to count, we're appending plus equals, we're appending the difference between the minimum of this and the last index. So it's going to be plus or minus, and then min of max k, max k ind x and min k ind x minus cut off index min L, where is this L coming from? Makes k return count. Run. How did we get a negative? Let's see. Conditionally, because these are set to can I do this? Sorry, why did it 0? Because they're set to -1 initially. Oh, sweet. Yeah, because they were set to -1 initially, sometimes we can get a min basically like +1, right? But we want the condition, the count, to be increased only in the case that count is positive. So if for some case, like for example, let's say that this is a 5. Oh, I can't edit this. If this was a 5, right, and we were only here, no, let's say here, then one of these max k's would be set to here, and we would be subtracting from this value. We would be subtracting from 1, we would be subtracting 3, and that would be -2, and -2 plus count would equal a negative, so this would whole thing messed up. So we always need to make sure that we are adding a positive value in the case. Oh, but then, so the min here would actually be, yeah, same thing for when we're, when one of these max k or min k's hasn't been set, the minimum value between these two would actually be the one that hasn't been reset yet, and so this condition would just be adding a 0. So, okay, let's see if we can pretty this up a little bit more to hopefully increase the performance. One thing I know off the top of my head is we can enumerate the nums array to avoid having to access it all the time. And let's remove these comments. Not that they actually do anything, it just makes the solution prettier. Okay, still not really beating a good amount. Okay, let's actually, I guess let's see what some of these other guys are doing, because I'm really out of ideas. What would be a good solution, a better solution? Min k max k, notice the subarrays 7 cannot be range of nums. So if max k is smaller than reset boundaries, seems like they're doing the same thing, except that, yeah, see the min max k plus 1, except that they are, how are they getting so much faster time? Well, honestly, what is it? 90 milliseconds. Oof. Okay, yeah, this is a very good approach as well. It's pretty similar. Yeah, I wouldn't worry about it too much. I think the solution here is fine, and it's, if it doesn't beat anyone in terms of speed, it does kind of is more intuitive. So yeah, feel free to use this, and thank you. Bye.